Hi everyone. This is example 5 from chapter 17 in your student packet. A new vaccine was recently tested to see if it could prevent the painful and recurrent ear infections that many infants suffer from. The Lancet, a medical journal, reported a study in which babies about a year old were randomly divided into two groups. One group received vaccinations, the other did not. During the following year, only 333 of the 2,455 vaccinated children had ear infections, compared to 499 of the 2,452 unvaccinated children in the control group. So it's asking us to find a 95% confidence interval. I just quickly want to talk about the assumptions and conditions. So it says that these were randomly, the kids were randomly divided into two groups. So we have random groups. There are millions of children, so I'm going to assume that the 10% condition is upheld. And in the first sample, we have 333 successes, which is much bigger than 10. And we'll also have more than 10 failures, the same thing with sample 2. And of course, these samples are independent of each other. So let's find a 95% confidence interval. And again, we're looking for a confidence interval between the difference. So we are going to do a 2 proportion Z interval because we have 2 samples involving proportions and we want to find the confidence interval looking at their difference. So we're going to go to stat tests and we're going to go all the way down, it's under B, to a 2 proportion Z interval. The X1 we'll choose to be 333, and N1 will be 2455. X2 will be 499, and N2 will be 2452, and our C level is going to be 0.95. And when we hit calculate on this, notice that we get a negative in our intervals. Negatives in our interval here. So we get. So I want you to remember that when a confidence interval is performed, we're taking P1 minus P2. And in our case, P1 was the vaccinated group, and P2 was the control group, the kids that were not vaccinated. So when we take P1 minus P2, we're hoping that the vaccine will mean that there are fewer ear infections, which means that when we take a smaller number minus a larger number, we should get a negative number. So this shows that the vaccine does give fewer ear infections. We can turn this around, so we can say that the confidence interval is this, with the idea that we are 95% confident that between 4.7% and 8.9% fewer children get recurrent ear infections if given the vaccine. So it says, use your interval to explain whether you think the vaccine is effective. Guess I did that already. That's kind of what I'm saying here. The entire interval is negative, which means I don't have 0 in the interval. 0 would have implied that there was a possibility that there was no difference between them. Part C, it says, suppose that instead of finding a confidence interval, you had conducted a test. what hypotheses would you have tested? So if we had done a 2 proportion z test instead, then the hypotheses would have been that, remember the null hypothesis is always that the proportions are the same. And in this case, the alternative hypothesis is the vaccine is going to give us, is going to mean that fewer children get reoccurring ear infections. So then P1 would have been less than P2, which is supported by our interval here. Part D says state a conclusion for the test based on your confidence interval, but don't actually run the test. So remember that the confidence interval was completely negative. The entire thing was below 0, which means that since 0 is not in the confidence interval, then P1 minus P2 is not going to be 0, meaning that P1 cannot be the same as P2. In fact, the entire thing was negative, meaning that P1 was less than P2 in our interval, which means that for our conclusion, we would have rejected the null hypothesis. So if we had run this as a test, we would have gotten a p-value that was below the significance level of 0.05. It says, if that conclusion is wrong, what type of error did you make? So in chapter 16, you learned about type 1 and type 2 errors. And a type 1 error occurs when you reject the null hypothesis, but it actually turns out that the null hypothesis was correct. And since our conclusion here was to reject the null hypothesis, it means that we could be making a type 1 error. What would be the consequence of such an error? So if we believe our test and we reject the null hypothesis, we're then saying that the vaccinations are effective. And if we're wrong, what would have ended up happening is that we give a whole bunch of kids vaccines that turn out to be ineffective against ear infections. So the consequence would be that children receive, spell receive right here, an ineffective vaccination.